So what I'm going to do is I'm actually going to start with cosine of 2u. I'm going to save this for the end, doing a substitution. What I'm going to do is I'm going to take my cosine of 2u. We're going to grab our cosine formula that uses just sines. I'm looking at my double angle formula from yesterday, where we have our 1 minus 2 sine squared u, right? We are going to, this was one of our equations from yesterday. Okay? That's just one of the ones we had, the double angle. We've done nothing different. Okay? We are going to solve this for sine. Get this to be a sine equals. So we're going to start by minus 1, minus 1. So we're going to have our, I don't know why I wrote it up there. Cosine of 2u minus 1 equals negative 2 sine squared u, right? I subtracted 1 from both sides. Getting sine by itself, divide by negative 2, be careful. So I divide everybody by negative 2. What we have is our, pretty much it's just going to be what it is, our negative cosine of 2u minus 1 over 2. I could deal with the negatives by making it 1 minus cosine of 2u. That would distribute the minus sign in. That's absolutely valid. Is that your question, David? Sine squared u. I do recommend that we do that because it's going to make things a little less gross. So I'm going to distribute this minus sign in so that we have negative cosine 2u plus 1, or that's the same thing as 1 minus cosine of 2u over 2. How do I get my sine squared to not be squared anymore? Square root both sides. So what we get is a plus or minus square root 1 minus cosine 2u over 2 equals sine of u. So this is like a whole lot of. The reason we're doing this is we're not actually trying to find sine of u. I want to be able to take and find a half angle. So what we're going to do right now is I'm going to substitute in v over 2. That's a v. I know the font looks darn near identical because computers are super awesome and we love the choices that they make every single time they make them. I'm going to actually scooch everybody up just a smidge right here so I can get a little bit more space. We are almost there. We have one more line to write before we're at our official formula. Because I want to substitute in that v over 2 for our u. The benefit of doing that is it's going to get rid of this 2 in here so we won't have a double angle. If I write this as our plus or minus square root, I'm going to have our over 2 here, 1 minus cosine of 2u becomes cosine of 2 times v over 2. What's going to happen if I do v over 2 times 2? Those 2's cancel out. So we'll just have that v in here. And that's going to equal sine of v over 2. So what this is if I have some angle, I can find sine of a half angle. So they're messy, and getting down here is kind of gross. It's doable, but it's unpleasant. So we can do it for all the others in a very similar way. I can take my cosine of 2u equation that uses just cosines. in a very similar process. In fact, I'm going to give us a little barrier here between them because they're going to start to, this page is going to look a mess, just saying. Because if we do the same thing using our cosine formula for the double angle, this one used sine squared so that we got all the way down to a sine. We're going to use our one that uses just cosine to get down to our cosine. So I can write this as my cosine of 2u, which is 2 cosine squared u minus 1. And we're solving to make our u be by itself, not the 2u. So it's a very similar vibe. We're going to subtract 1 from both sides to get our cosine 2u minus, plus 1, excuse me, is our 2 cosine squared u. Dividing both sides by 2, I'm going to switch colors just because it's going to start to blend in, but I also need to make sure we stay close together so we don't run out of space. Our cosine 2u plus 1 divided by 2 gives us our cosine squared. Right? You see that? Mm-hmm. Square root both sides. We get our plus or minus square root cosine 2u plus 1 all over 2 equals our cosine of u. And the benefit of that is then when we substitute out for our v over 2, it's going to cancel out in the middle. So our plus or minus square root cosine of v plus 1 over 2 equals our cosine of v over 2. So I told you, these guys look super gross. They look super gross, though. So that's why I'm saying these ones were the scariest looking formulas. What's up? From here up, it was of u. These down here, these are v. This is where we switch to v. Because we're trying to find the formula for v over 2. We want our cosine v over 2. We had sine v over 2 over here. We want cosine v over 2. These are our half angle formulas. That's what we're trying to build. Okay. For tangent, well, I've got sine. I've got cosine. Let's not start from scratch. I've got sine of v over 2. I've got cosine of v over 2. We're going to use them to build tangent, not go back to the double angle.
So you just put that.
Mm-hmm. I would say they're a little bit messy, but this is actually less awful than trying to go back to the double angle. So to get tangent of v over 2, we're going to do our sine of v over 2 over our cosine of v over 2. So we have those pieces. They're messy, but we can do it. We're going to have our fraction that has fractions in it. I'm going to switch my greens just a little bit so that we have our sine, which is our plus or minus. We had our 1 minus cosine of v over 2. Our cosine is our 1 plus cosine of v over 2. Or cosine of v plus 1. Doesn't matter what order we put it in. What do we notice? The 2's are going to cancel out. And since everybody's in a square root, let's just make it 1 square root. Because, ew. So I could write this as our plus or minus. It is not 1, but it's close. 1 minus cosine of v over our 1 plus cosine of v. So they're the scariest looking, definitely. And then the puppets are. That's why I always get the safety one. That means it caught on the drawer somewhere, and I would have. Oh. Okay, this one's a very, very formula heavy chapter. These are, I'm gonna go with our, just double checking before I make anything kind of claims like that. I think these are the last ones for the chapter. Should be. I'm pretty sure that's next chapter. Okay, so this is where these formulas are coming from and how we get there. To have them written less nastily up on the screen, looks like this. So instead of me just handing them to you blindly, we can write them like this. Tangent has a couple other ways you can write it by rationalizing to get rid of that square root. So here's a couple alternate versions of tangent using the same pieces. It's just rationalizing out our 1 plus cosine, multiplying by the conjugate. We'll get these when we simplify. If you want to work them out, more power to you, but you can also just go with, I believe you. I mean, you can get it from the other ones. Like it comes from the other tangent one. What's up?
For the tangent one, though, I don't think I was listening. I think I was just writing.
Mm-hmm.
But when you said when you put like the square root over a square root,
Mm-hmm.
where do you get the cosines? Like, why do you put them like 1 minus cosine of v over 2?
So on these ones, I took my sine, this guy over here.
Oh.
That was my numerator.
Okay.
My cosine was this guy here. And since I had a square root over a square root, I can use my radical properties and be like, that's the same thing as if it's all under the same square root. Because it's not a square root inside of a square root. They're just a stacked fraction.
Thank you.
Yep. No worries. 100%. Totally cool. I'm happy to explain it because these are weird and awkward and uncomfortable. And I know we look at them and we go, why? We have to see why. So, the reason we have these is because sometimes we ask you guys to find angles that are not things we know. So, cosine of 165. 165 is not one of our unit circle angles. Right? What is 165 times 2? 330. So if I take 165 degrees, that's the same thing as 330 divided by 2, right?
Yes.
Do we know 330?
Yes.
Yes. So if we set this up where we have 165, which is my v over 2, because this is v over 2, 165, right?
Why is that V?
Because I want 165. 165 is the same thing as 330 over 2, yes?
Yeah.
Cosine of v over 2. This is the same thing as if I wrote cosine of 330 over 2. Yes?
Oh. Okay.
Okay. So our v, cosine of v, is cosine of 330. So using those formulas, which I know are darn near microscopic up there, we're going to fill in the pieces. So we're going to look at our plus or minus square root. We're looking at our cosine, so that's our 1 plus cosine of 330 degrees over 2. What is the cosine of 330 degrees?
Square root 3.
Mm-hmm. So we have 1 plus root 3 over 2 over 2. Can we simplify that? Yes. Plus or minus. What can we simplify? Say it again. Yeah, let's get the numerator to be into a common denominator first. So I can take my 1 plus root 3 over 2 and make this 2 plus root 3 all over 2, and then that's all over 2. So what do we have next? They don't cancel. Because I have something that's divided in half that's being then divided in half. Yeah, so it would be the same thing as if I had 2 plus root 3 over 2 times 1 over 2. So this is going to be the same thing as, I'm going to put this on one line, our square root 2 plus root 3 over 4. Is there anything I can simplify now? You could. There's an easier option for simplifying right now, because what do we have that we really shouldn't have when we get to the bottom of an answer? I was going to say I've got a radical over my denominator piece here. Because this is the same thing as square root of 2 root 3 over square root of 4. Over 2. So this thing is going to have our plus or minus. We've got our root 2 plus root 3 over 2. One last thing we're going to think about. Angle 165 is in what quadrant? Hang on a second. Different question. Think of angle 165. Quadrant 2. Cosines in quadrant 2, are they positive or are they negative? Negative. So do I need to keep the plus or minus? No, because we know it's going to be negative because it's in quadrant 2.
Where do we get quadrant 2 again?
Angle 165.
Oh, okay.
So we can use the number that we got. So our cosine of 165 is this mess where we have a negative root 2 plus root 3 all over 2. And that's our answer. There is not a way to make those less gross. They're going to have roots in roots. That's how it is. They're gross, but they're there. I say they look really scary. Yes, my dear. What's up, Reese?
How did you get a 4 on the bottom?
Because we had our 2 root 3 over 2, that's all divided by 2. If it helps, you can think of it as our 2 root 3 over 2 multiplied by the reciprocal times 1 over 2. Okay, so that's when we multiply across to get our 2, oh, plus, sorry, there's a plus in there. Plus root 3 over 4. Okay. So we're going to do a very similar thing for sine of 105. I'm just going to, again, give us a little bit of review here so we don't merge things together. So do we know angle 105?
No.
What is twice 105? 210. Do we know 210?
Yeah.
Yeah. So we're going to use the fact that 105 times 2 is 210. That's the same thing as if we had that 105 is 210 divided by 2. So when we're filling in our sine formula, what's my V? The 210. So looking at our sine, that V is the 210. Take your time on that part, because honestly, that's the part where things get a little wonky sometimes. So filling in these pieces using our sine formula now, we're going to have our plus or minus square root of 1 minus our cosine of 210 all over 2. What is cosine of 210? Ooh, I have heard many choices. Looking for the cosine. It's a root 3 over 2. And it's negative. Agreed. So this is our 1 minus negative root 3 over 2. All over 2. So be really careful. It's super important that we, oh, that's not the highlighter, that we get these really careful. So be super careful with these pieces. That is the exact same color I used for a different thought. We need to change that color. Here we go. These pieces we need to be really careful with. I don't want to highlight in the same thing when they're separate thoughts. So now we're going to simplify this. Yes, I've got a double negative here, so they're going to wind up being added together. So we're going to have our plus or minus square root. Yes, and we can get to our common denominator here with our 2 plus root 3 over 2 all over 2. So this one became from common denominatoring these guys. Simplifying this numerator, our 1 minus square root of 3 over 2. I got those guys to be a common denominator here so that I can then simplify this double fraction grossness. Because this is going to turn into our plus or minus square root of 2 plus root 3 over 4. So is 105 going to have a positive sign or a negative sign? Because what quadrant is 105 in?
Positive.
I'm going to say it's in quadrant 2, so our sign's going to be positive. Look at the original 105. So we're going to have our positive small square root of 2 plus root 3 all over 2. Okay. Let's do one more like this, and then we'll do more like the ones we did yesterday, but using the same kind of stuff. So let's do tangent of 22.5 degrees. So tangent of 22.5. 22.5 is half of what? 45. So 22.5 degrees is the same thing as 45 degrees divided by 2. So when we're looking at our formula over here, where we're asked to find our tangent, our V is going to be our 45. So looking in here, we're going to fill in our pieces. So we're going to get our tangent of 45 over 2 is going to be our plus or minus square root of our fraction that has our 1 minus the cosine of 45 degrees over 1 plus our cosine of 45 degrees. What is cosine of 45 degrees? Square root of 2 over 2. So for both of them, I replace it with that. So we're going to have this be our plus or minus our gigantic square root of 1 minus root 2 over 2 and 1 plus root 2 over 2. So what can I do to try and simplify this absolute mess? Before we do that, yeah, let's common denominator these guys. Let's get the fractions out of the fraction. Make it a single fraction, single layer. So we're going to still have our giant root here. This becomes 2 minus root 2 over 2, and then we're all over 2 plus root 2 over 2. Be more specific about which 2's cancel, because there's a gabillion. Yeah, our over 2's. Those guys cancel out. So we can write this as our plus or minus square root of 2 minus root 2 over 2 plus root 2. And we're going to stop right there. All we got to do now is figure out our sign. When we have these roots inside roots inside roots, trying to rationalize this is an absolute nightmare. We are going to leave them like this. This is going to be one of the only times in here that we leave radicals in denominators.
Yay.
If I have a radical inside a radical, we don't have to rationalize because I'm not that mean, basically. So last thing we have to do is figure out if we are a positive or a negative here. Why are we positive? Because we're in quadrant 1. And sine over cosine, when we have both positive sines and cosines, is going to be positive. So we have our positive 2 minus root 2 over 2 plus root 2. And we stop right there. Okay? So they're scary looking and very gross. We can do them, but they're gross. So the other way questions are worded in this section, the last bit, is going to be just like the ones we did yesterday, but using our half angles instead. So, things like these, where we have cosine of some angle. What's up? Okay. Cosine of some angle. I know my theta is between pi over 2 and pi. And we're finding tangent of pi over 2. So, what quadrant are we in here? 2. Quadrant 2. Because we're between pi over 2 and pi. So, we're asked to find tangent of theta over 2. And I know cosine of theta. Do I need to figure out anything else about theta before I can start going? Because if we look at our tangent formula, that is, I was going to say, objectively, it is tiny. So let me this. If we look at our tangent formula, I've got one that's just got cosines in it. In fact, that's one we've used most, is this guy. He's just got cosine. So we can go ahead and just use that equation. Really? We don't have to figure out anything else about it. We don't have to draw the triangle. I was going to say, all we have to do is remember that we've got to figure out our sign. Are we going to be positive or negative? So let's think about this. If we fill in our formula for tangent of theta over 2, we're going to have our plus or minus our square root of our 1 minus negative 11 over 61 all over 1 plus negative 11. What's up? The ones we just did? We did. Oh, when we had cosine, we didn't have cosine here. We had to figure it out because we knew it was 45. So on this one, we are given basically v. We're given cosine of v, and we're finding v over 2. Do we know cosine of 165? That's why. So let's see what we can do here. Let's simplify this a bit. We're going to have our plus or minus. What can we do with our numerator? What are we going to get up there? 1 minus negative 11 over 61. 72 over 61. Common denominator, 61 over 61 minus negative 11. Simplifying it. What do we get in our denominator of 1 plus negative 11 over 61? 50 over 61. Our over 61s cancel. So we have our plus or minus square root of 72 over 50. Will that simplify it all? They're both divisible by 2. So we're going to have our plus or minus square root of, what do we get when we simplify it by 2? 36 over 25. So can we simplify this more?
Yes.
Yeah.
It's just 6 over.
Square root of 36 is 6. Square root of 25 is 5. All we have left to do is to figure out our sign.
It's negative because it's cosine and the quadrant.
Ooh, wait, what did we find? We found tangent in quadrant 2, which is going to be negative. So tangent in quadrant 2 is negative. Because in quadrant 2 we have cosines that are negative, sines that are positive. Positive over a negative is going to give us a negative. Okay? So that's kind of the vibe for the rest of this. Okay?
We're done.
I mean, everything else is the rest of it. It is a Tuesday, not a Friday. Just saying.
How many questions on the quiz?
It'll be a... I haven't printed them yet. I don't remember.
20, maybe.
How do we get 22 over 61?
Oh, we did common denominators here. So I can write my 1 as 61 over 61.
Never mind. Yeah.
Okay, cool. Okay, so our half angle formulas are the last ones that we have in section 7.3, or 4. This is 7.4. I do have for you guys, because I know you guys like to have them, practice for the quiz, a little review. It's got some of every kind. So we've got angle, sum, and difference. We've got a page for our double angles and a page for our half angles. That's why it's the only reason. So it's a separate page for each kind of thought. So our sum and difference, double angles, half angles. Okay? So we'll be all right. The hardest part is the formulas, honestly. Okay? We'll be okay. I promise. I promise we'll be
How much?
okay.
We get 20 minutes, right?
That is the standard amount, yes. So I am making a slight adjustment to the homework. 17 and 19 on the homework are optional because we're not going to go into verifying problems together.
Yeah.
There are 2 verifying problems on the homework.
Can we get extra credit?
Yeah, can we get extra credit for that?
Sure.
Oh, okay.
Is it like one for each problem or like one for each?
Huh?
Or
We can do one for each problem. I'm cool with that.
Okay.
It's pulled back in a ponytail, dude.